Monad, functor, and applicative Swift functions are something really from functional programming languages like Haskell. But we can use it to perhaps turn some code like this into some code that looks more like this. Let's take a look. Swift's map is great. It allows you to apply a function to every element in a sequence. So that might be an array, could be a dictionary, could be a set, any type of sequence. The issue is map always returns an array. It can't generalize and return the same sequence as has been fed in. What we need is a kind that can generalize over type constructors. And Swift doesn't actually support that, it's higher kind of types. But we can think theoretically of what that might mean, and if you are able to say map over a dictionary and return a dictionary. Swift's optional is already a functor. That's because an optional essentially wraps a type in an optional. So an optional, either the value is there or it is not there. This is represented in the Swift standard library as an enum. A functor allows a mapping to occur from a type to another type. So when you map on an optional, either the map happens and you returned the resultant value with the function applied, or nil can be returned. So a optional with a function can return an optional. This means that an optional is a functor. A monad is a type that defines flat map. Swift's optional in the Swift standard library defines flat map, therefore the optional is a monad. So Swift doesn't actually have applicative functors, so we could implement it in our own optional type. So we can create an optional where values are either there or not. You've kind of got a wrapped value, which is the type underneath the optional. And then you can have an apply type, where essentially an optional function is applied to a wrapped value in an optional, and it returns an optional type. So we apply the function using flat map and then map over it. So you would have a function like this. If we have that apply, then we can have a function like at the very beginning of this video. So it replaces this more complex function with this if you had applicative functor. Now of course, we have to have our own optional type in order to achieve this. But the point is, with functional languages, you start to get this rather nice code which is shorter and easier to use, and certainly gives something to think about when we're writing our own Swift code. I hope that video was of use to you. Do feel free to comment or to follow me on any of the social media channels, and there's a link to the code in the description. Thanks for watching.